All right, afternoon, everybody. How are you? Good, good. Welcome to day whatever it is. It feels like day 20. It's like day 2 or 3, whatever. Hope you're having a good RSA so far. Hey, how many people's first time to RSA? How many of you? Wow, that's a good number. Yeah, I think this is like 15 or 16 years in a row for some of us, but welcome. It's close to where it used to be. We were just saying earlier before pre-COVID, enough people are now here. But one thing that's pretty awesome about RSA is there's a lot of like-minded people, a lot of shared knowledge, and also there's a lot of FUD. And you probably get overwhelmed by some things. And actually, we're going to talk about one you're probably sick of hearing, which is AI. Who's been to the expo floor? Yeah? Every single booth has AI somewhere on it, right, plastered around. And then the challenge is it's hard to decipher, where it actually is useful and where is it just noise to get you to stop by or get some analyst to kind of give you a checkbox of what you're doing. So the goal today is to really just talk about that. What's the reality about AI? Can it actually help? How does it help? What's, I think, ridiculous claims? What are realistic claims? And then James is going to come up and actually show you some uses of this live for you. So who the heck am I? My name is Mike Nichols. I was a practitioner for many, many years. Army Intel, worked at many SOCs. The largest one was probably DHS for many years. Now I do product stuff over at Elastic. We're an open source company. I think what I like about what we're going to talk about to you is it's more about just kind of the community's feelings of things, and I can tell you the feelings of AI being overwhelming and maybe noisy. But I'm going to tell you the reality of it. It actually does a lot of cool stuff. But how do you do it the right way, and how can you implement it in your organization? And feel free to ask questions later on. We'll have a Q&A section with some microphones here. You can come on up and ask what you need to. We can touch on governance, we can touch on risk, we can touch on efficacy and hallucinations and all the things you love to talk about. Sovereignty, happy to talk about all of it when it comes to AI. It's an evolving space. I think every day there's something new, but that's the goal. James works on my team. He's our AI lead, so again, don't beat up AI too much, but he's doing some good work with it. Disclaimer, you read through it. Basically, my views are not the views of RSA, yada, yada, but keep an eye on those things. All right, so, what is AI other than just, kind of searching what fancy stuff? We've come a long way through how we look at data, and the reality is that data's gotten so exponential and there's so much of it, we need help. Like, we used to be able to sift through it ourselves. I remember too many years ago, I was in a SANS course using Super Timeline. Everybody remember this? Like macro you would run on Excel, you'd bring the logs in, it would munge it all, color code it, and then put it in order of time operations so you could actually find out what's happening, sort of the way we were doing forensics way back when. But you can't do that anymore. There's no super timeline for the exponential, petabytes of data coming in from the cloud and everything else in the environment. So how does a defender make use of that information? How do they find the proverbial needle in the stack of needles? And there's lots of ways to look at this. We've used things like machine learning to find anomalies and all kinds of cool tech. AI is just yet another part of the tech stack. AI is not the answer. AI is part of an answer, right? You'll hear people talk about hybrid often. I think that's usually the case here as well. AI is not the way to always solve every problem. Sometimes it's too expensive. Sometimes it might hallucinate. But when added to the rest of the suite, we actually think it provides a lot of additional value to what we're doing. There's challenges, right? AI has a lot of challenges. Hallucinations we keep coming up. That's a big one, right? And I think what's been great for security teams, if you go back to the world of ML and when we all sort of started seeing that, I was in an early stage when it wasn't even UABA. It was a UBA, user behavior analytics company that was using machine learning. It was really used mostly in security, and so we didn't get a lot of the benefit of the rest of the world's push. The great thing about AI is it's being used everywhere. I mean, there isn't a product you use today that doesn't have it, like your cell phone in your pocket or even your bank now. And so those innovations that are happening in the world, we get to benefit from. And I think a big one that I like a lot, if anybody uses ChatGPT, you'll notice lately, is now it's starting to show its work. It's sort of telling you what's happening. There's no more black box or less of a black box. That was a big thing about hallucinations. It's maybe 6 months ago, you'd ask a question to give you an answer. How did you get this? I don't know. Good luck. I hope it works. Now it's getting more and more responsive about telling you how it finds the information that's there, explaining that, here's the sources, go read them for yourself, which I think is really what we want. We want AI to be kind of the collector of information, but not act as if it's the sole proprietor of that data. It actually tells you where it came from. James will talk a little bit about that idea, that how can I add citations into information for security? How can I kind of show the analyst where this information comes from to be able to get the validity of it? The tech stack is harsh. I mean, everybody's, I want a vector database. I want to add that to the already overwhelming stuff I need to manage. Do you need it? How many pieces are there? Privacy and data. Is anybody here still not allowed to use AI in the organization from a policy standpoint? Hopefully they've started, a few of you? Yeah. It's hard to imagine. I feel for CISOs. If there are any CISOs in the room, I really feel for you because the ability to reduce this is kind of impossible now. Right? Pick up your cell phone and you can get ChatGPT right there. You can't block that from your corporate environment. And so how do I actually then teach people how to use this in a good way, right? And how do I prevent things like prompt injections and other areas that might be coming in? And that's where we get the security side of it. We're seeing more and more examples of how easy it is to confuse AI. AI is almost like a really inquisitive fifth grader who is like really excited to help us, but then you tell them one wrong thing, like, oh yeah, you're right, 1 and 1 is 12. Here's the answer. And we're seeing this in many ways where, in fact, there was one of our researchers did a recent example where you could poison the sort of knowledge of an LLM, and they would actually give you back the malicious links instead of actually telling you how to solve the problem. So we got to get better about the privacy of this, but that's the whole point of showing your work and digging in. So with all those scary things, like why the heck are we even using this? Well, the benefit is that it actually is able to accelerate what is the biggest problem we've had for now 20 plus years in security, which is a people challenge. We don't have enough people to do the problem. We never get money for it. I always, a part of the business in Elastic is also observability, and I love that side because as your business grows, it's like easy to say I need more SREs. It's like revenue goes up, more people at the website, I need more SREs to do the job. In security, the better we do, the less things happen. And so now you get to sell a negative to the business. Oh, I need more analysts. Why? Because nothing's happening in the environment, and we're doing such a great job. So it's really hard to show why you need a stronger team, why you need more people that are there, and you end up with people that are burned out. Like you look at thousands of alerts a day. I remember going in some, I won't say where, some SOCs I worked at, and you'd walk in the morning and just flush the alerts and start over because you can't catch up. It's just impossible. So how can I do things like prioritization? How can I find the problems, the serendipity discoveries? And what's really compounded this issue now is distributed work. I love it. It's the ethos of Elastic is distributed. But I can't tell you how much of the time in a SOC I would find a problem because I'm working on something and two seats down someone else is, and we talk to each other. And that's really where we discover that it's an ongoing issue or persistent issue. How do you do that in the remote environment? You need somebody or something that's sort of funneling that information back to the analyst as you're sitting there at your desk or at a coffee shop. That sort of persistent knowledge base. We all have the process. I'm sure in your SOC there's a process somewhere that says, hey, once you're done and you've resolved this issue, write it up or put it in the wiki or feed it back to the system. Nobody does that. I'm a big believer of the OODA loop. I don't call it a loop in most places. It's sort of OODA, and at the end it's just a big break. Because you never feed that data back. You don't have time. You have 10,000 more alerts to dig through. What AI can really help do is sort of feed that information back into the system. So then you get to how the heck do I use it? Well, it looks difficult unless you kind of peel back the onions a little bit. Many people I see are trying to use the existing models and then tune them for their organization, right? You have a data science team, they're trying to munge it to make it work for you. It's expensive, and the challenge is especially in security, in 5 minutes it's out of date, right? It's changing so quickly that those bespoke models don't make sense in an adversarial world that's moving faster than we can possibly do it. You can pre-train a model. Again, expensive, data scientists involved. It does work, right? But what we like to say is there are billions of dollars investments in these hyperscaler models now, things like Google and Amazon and Microsoft. Why not leverage the investment they're already making? So how can I do that? Well, we're big believers in retrieval augmented generation, which James will go into a lot of depth on. But the basic idea is, if you look at how you talk to an LLM, it's pretty simple. You have a question, like ChatGPT, ask a question. That goes out to the LLM, but there's also a little secret piece that in ChatGPT can't do, but in other products or in other areas of accessing AI you can, which is called the context window. And the context window is where you can shove in more information that it will take into consideration as it answers your question. So as an example, if I go ask, let's say Gemini in Google, how do I resolve an incident of an infected endpoint from blah, blah? It'll say, hey, in the vast world of knowledge of the world, here's the best way to remediate step by step by step. But that has no information about my organization. It doesn't know who I should contact, who's my IT lead, who's this belong to, right? Where's my CMDB information within that? If you are able to inject into that context window that data, right? Give it things like, here's my incident response playbook, or here's my asset database, and send that up with the question, what the prompt can do, what the LLM can do is say, here's how to remediate, and in the steps, it can also say, by the way, go contact Jane. She runs this administration piece. Or this is actually the CFO's laptop, and he's right now giving a talk to investors, so maybe don't mess with it, right? So there's these different pieces you can know only if you have that context to really make it bespoke for your environment. And what RAG is, it's actually pretty inexpensive to implement. We'll show you how you do it here in a few minutes. So how do we apply RAG? Well, I think, James, maybe you want to take some of the details here, since you're the RAG expert as we talk about how to actually implement these things within an organization.
Absolutely. Thanks, Mike. Yeah. Hi, everyone. Thanks for joining us. So RAG stands for Retrieval Augmented Generation, as Mike was saying. It's basically a very fancy way of saying how do we cleverly inject context to that context window. So you need a couple of things. You need a couple of moving parts. First thing is you need something called an embeddings model. So an embeddings model grabs standard text or even images and audio and that sort of things, and it creates a mathematical representation of that data. That mathematical representation basically allows us to run natural language searches on it. So once you have that embeddings model which generates these embeddings, this is where the effectiveness of RAG really comes in. Of course, you also need a way to store those embeddings. So not every data store in the world can store embeddings. There's quite a few out there, and it's become more and more popular as generative AI has been ramping up. But you need a place to store those vectorized content, that vectorized content. Plus any generic data store as well, right? Because where this really gets advantageous is if you combine semantic-based searches, like natural language processing, with standard keyword-based searches. Like we call it BM25, but basically it's the traditional, hey, I have a keyword, let me search it within this corpus of data. So once you have that combination of both, things start to really ramp up in terms of the capabilities. Of course, you need a large language model to stitch everything together. When I say stitch everything together, it is what's going to make sense of the additional context that you've provided. The great things about these models are once you give it further information, and then you get the right answer. Like that's the beauty of them. The models are able to discern this retrieved content and tell you, okay, based on what you're asking me, here is the right answer for you based on the additional context you provided. And then the last step is if you're really building out these technologies with RAG, you need an orchestration layer. An orchestration layer is what does all these moving parts. It's what grabs the embeddings. It's what decides what kind of query to run. It's what sends them to the model. It's what instructs the model what data is actually available to it. These orchestration frameworks are very plentiful as well today. You have things like LangChain, you have things like Llama Index. There's many, many of them. Or you can even use the direct functions from the model providers as well. This slide basically just explains everything I spoke about. But once you have all these moving parts, you can do really amazing things. This slide basically is showing what embeddings actually look like. It's pretty cool. So if you haven't seen what this mathematical representation of data looks like, you have on the left-hand side basically the actual text, and then on the right-hand side, the vectorized representation of it. So it looks like garbage. But when you run a semantic search, that's actually what it's using. It's using all this really cool information under the hood. Should I hand back over to you, Mike?
Yeah, sure. So how do you apply this then in security? And I think a key piece that mentioned on that previous slide is that the reason it looks like garbage, or the reason we do that, is you can actually add a huge amount of context now to these questions. I mean massive amounts of information can be added to the question. And there's models out there today, I mentioned Google a few times, like their context window is so large at this point that you can send, what is it, is it 2 million? Or
2 million.
Yeah, 2 million. So it's kind of ridiculous how large these context windows get, and over the time, it's gotten cheaper and cheaper. The windows get bigger and bigger. So in a few years, I mean, you can kind of add whatever you want. Maybe the Library of Congress can go inside of the information you get. But the point is, that's how you get very bespoke answers. So if you're looking at the kind of new revolution, evolution, whatever you want to call it, of SIMs, or of security analytics in general, the point is, when you go talk to either a vendor or you apply it yourself, you want to make sure that when you work with an LLM, you aren't just asking a question, getting an answer that it knows from its global knowledge. Or a lot of vendors out there are now training their own models and saying, hey, here, this is for you. That's great for this very specific use case, but if it can't embed your bespoke information, it can't give you the answer that's unique for your organization. So it could be useful, but then your analysts still need to do things like check your wiki, check your incident response playbook. The whole point of AI in our minds is to remove any additional workflow steps and also not create a new thing you need to do. You don't have to retrain them and say, oh, pause here and go search in this. It needs to fit into the workflow of the analysts themselves. So getting all that context directly into the system is how really we think the evolution or revolution or whatever evolution of the security world will go. And we look at it this way. So back to OODA. I love OODA. If you don't know what it is, it's a really cool framework that was defined a long, long time ago in the Air Force by a pilot about how you basically make decisions quickly with an evidence-based approach to solving these challenges. So you sort of look at ways you can apply this. These are just ideas that we'll showcase a few of these, but ways you can think about how can I use AI in the decision processing. Does it understand what's wrong in my, I have an engineer who's doing fixing the systems. Does it know that data dropped? How many people that run a SIM today, as an analyst, this happened to me a lot, you're looking for something and you say, oh, there's no results. Well, is it no results because you actually got 0 hits on the data, or did a forwarder somewhere die and you haven't gotten data for 2 weeks and you don't know that? Or did the system sending you information change the format because some update came out and actually the field you looked for changed to now instead of source.dest or source.ip, it's ip.source or something, and now all of a sudden it's not there. So is it truly a hit, or is it a false negative that it is there but you just didn't search for it the right way? AI is really good at identifying those things for us and saying, hey, actually, you're looking at data, it doesn't exist, or these fields might need to be modified. Orientation is about kind of giving us context. James will show this, but the whole thing I look at is that serendipity moment or the not dropping thousands of alerts moment where, how do I know that somewhere in this stack of alerts is a real problem? There's lots of ways to look at this. We all have our games we play as analysts. We would group, we would sort, we'd filter, we'd look for corresponding IOCs. But the real beauty that machines can do that we can't do as quickly is connecting the dots from behaviors. So I'll give you an example. When you feed the context of the MITRE ATT&CK framework into an LLM as context, and you ask it to evaluate your rules, what it can do is it knows things like, here's the attacker TTP. And it says, hey, I see an alert over here that was, for example, an inbound potential reconnaissance thing, and then later here I see potential exfil, and I know from the context you've given me that there's an adversary that uses these two techniques in their attacks, so you can stitch them together, and then say, hey, this might be of interest, and actually prioritize those two things together. That's the benefit. Would an analyst do that? Of course, that's the expertise they have, but them going one by one through your thousands of alerts, how long is their memory going to keep this? Oh, I saw something an hour ago that connects to this. So can AI be used to find those connections that we know we could find as a human, but we just can't be fast enough with the amount of data coming through? Into the decision piece, everybody's seen this, the buddy in a box. Yeah, I need help. How can I train my team up faster? How can I take my tier 3's expertise and bring it down to my tier 1s without bothering my tier 3's to do their jobs? That's that old knowledge base idea. You solved an incident this way. Can that incident information get fed back to that tier 1? So when it pops up for them, they go, oh, somebody did this before. Here's the steps they followed. And then into finally the feeding back into the actual fixing of the product. Tailoring rules, tuning rules, updating threat hunts, all the things you want to do that you never have time for, AI can also help prioritize and automate those things. And again, you believe me when we actually show it to you, but that's the whole point. So if I were in your seat and I'm looking at either buying or implementing a solution that could use AI, key questions to ask are things like, how can I get my bespoke content into this so it isn't just giving me the generic answers? Or can it actually fit into my workflow versus creating a new workflow? One thing we love to joke about is you go across RSA's floors, there's amazing demos, but what happens at the end of the demo? What's the how do I actually then do the next step? Can I actually solve a problem all the way to the end? And that's a good place to talk about, is AI actually fully implemented, or is it just there to be sort of a tagline for marketing? So there's some cool stuff about RAG that we've written up. I mean, you can go anywhere and look at it. You can ask ChatGPT about RAG, it'll tell you. But if you want to go read stuff we have some pretty cool papers we put out, things like how to use RAG in depth, how to, the basis of RAG, the advanced steps of RAG. In general, you can even, Elastic's open source, totally free. You can go build your own RAG application if you wanted to. Just have fun and go at it. Or on our side, we'll show you what we can do. You can use ours as well if you wanted to, one we already built. But we're finding more and more companies like to build these things, things like customer success implementations, or we even have one for our field teams to help them prioritize and answer questions. So really interesting ways you can start to do this and start to kind of collect the global knowledge of your teams. It isn't scary if you put it the right way, but definitely I think James will show you some ways to do it the right way. And for Q&A, we can talk about ways that are maybe challenging or incorrect ways to implement these solutions. So with all that talk and all that fun, let's get out of slides and let's actually go to the demo. I think that's where the coolest part of this whole conversation goes. So, James?
Yeah, thanks, Mike, and thanks for hyping up everything about the show, which is awesome. All right, so let's switch over here. Now, I'm going to be showing you all of this in Elasticland just because I have easy access to it, of course. But this, you can get access, everything I'm about to show. What's really important is you take away the concepts that we're showing, right, versus what only lives in Elastic. So that's just really important. We've been doing this now in terms of our generative AI journey, we've been doing this for about 2 years. So we've learned a lot along the way, and we just love sharing what we've learned because we want to make the community better. And this is a really good opportunity to share some of the things we found really valuable for users across the board. Let's start with one of the things that really excites us, something Mike was saying, like how can we use RAG and this concept of AI with large language models to help with this problem? Like what you're looking at here is an alert screen, right? This is an alert screen. This is what the industry believes is the norm, right? I log into my whatever security tool I'm using, and it tells me, hey, you have all these things to deal with. In my situation for this demo today, I have 121 alerts, which is a relatively small number, right? If you are working on a security operations team, you know you deal with way more. And traditionally, the way to figure out what is even going on with those 121 things is you go through a long list like this one here, and you start to go through each and every one of these things manually. I have malware detections here. I have stuff coming from SentinelOne. I have data exfiltration. Where do I even start? More importantly as well is not only where do I start, how to make sure that what I'm actually investigating are the alerts that are the riskiest to my organization. Because that's typically what happens, right? You spend time investigating a lot of benign stuff, and then what happens is what I actually should be focusing on most, it's already too late because it was further down in my list as an example. So how have we thought about like fixing this, like how, some of the things we recommend? So this goes back to that, we have in Elastic, we call this attack discovery, but what we do under the hood is it's a very simple interface because we don't want to introduce like new challenges for teams. We want it to be as simple as possible. And what it's going to do is when I hit that generate button, it does the process that a human would typically do, but as Mike was saying, is it will stitch those data points together faster. So we'll retrieve that alert context with that retrieval augmented generation concept that we were talking about. We send them to the model with very specific instructions about what to look for, how to act, what to do, and then see if you spot anything that's of interest to me. And that's what's really important, of interest to me and my organization, not just something generic. I'll point out that the only configuration that you have on the screen is the large language model. So again, we're firm believers and we think the right approach is to allow users to bring whatever large language model they prefer, or realistically, whatever large language model they're allowed to use in their organization. Because you don't have access to every model. You've been directed to use something from Azure or from Amazon or Google. So we give you that freedom. You might also be directed or live in an air-gapped ecosystem where you can't have these connections, right? So if you want to host your own model, we believe that's something you should be able to do. So you should have that freedom of choice as well. You'll see things like Mistral in my list. That's an open source model as an example. So once you do that, once you select that, you hit the generate button, and then in the background, it's going to go start doing all of that work. Just because this could take a few minutes, I did run this just a bit before the presentation, just so we don't have to stay waiting for the model to do its thing. And here we go. So I ran this 32 minutes ago. So I'll talk you through a bit of how we decided to present this to a user. And again, this is based off of feedback that we got over various months to say, look, how can we make AI useful for you? And this is why we're sharing it today, because of some of the stuff we've learned and some of the things our users really appreciate. So Attack Discovery ran, and it basically said this. It said, look, you started off with those 121 alerts or so. We found that 18 of those 121 are causing you a bit of a headache. It's something you should absolutely want to look at first and foremost. It's not to say the rest of the 100 or so go away. It's basically saying the content that we've seen in there, it can wait. It's not as important as what we're seeing right here on the screen. But we don't just stop there. We try and look within those 18 alerts to see, did we actually discover any active attacks of interest? And in this case, there were 2 active attacks. So we went from that huge list of 121 things as a user that would typically need to go through that manually. And now my focus is, okay, here are the things that I should absolutely spend my time more on than anything else. And you'll notice this is in chat, right? So like, even though we're using a large language model here, one of the things we wanted to make sure to do is, how do we help our users in a way they're familiar with working? We don't want them to have to chat to get to this experience. And also, you can still apply that retrieval augmented generation concept on anything. You can have full dedicated workflows bespoke to how your users are used to working. So it's not just a chat thing. In this case, here's how we felt we should lay out the information for the user. So the attack is labeled as there was a malware port scan and data exfiltration via Slack. As Mike was saying, because one of the things we found really useful to be able to do with RAG is we feed it all that MITRE attack context. And here we show users the tactics that were involved. And this is really how, and then a large language model is able to make a decision about how to stitch things together. It's a really powerful thing. Thankfully, because there's so much information about MITRE in the community as well, these models have a fairly good understanding of what there is, but when you supplement that additional context with RAG, it gets even better, which is really cool. So these are the 8 tactics which are involved. We see out of those 18 alerts, 11 are involved with this attack. And full transparency, you can see those as well, which is also really important, as Mike was saying. Anything you do, if you're designing a system or trying to implement a product which is using AI, it's really important that you show users like how this ended up to be or why this attack actually happened or whatever. Just be transparent with what you're doing. And let's get to the crux of the actual content. Hopefully you can see that on the screen there. I'll try and zoom in as much as possible. But if we just read the summary alone, it says there was malicious activity detected on this Windows host and this other Linux host. User James, it's always James, opened a malicious Excel document leading to the execution of malware, a port scan, and data exfiltration to Slack. Even just those 2 sentences, it's pretty golden, right? Like, not to say that a human wouldn't have been able to come to that conclusion, but it would have taken hours to come to that conclusion. And this is true. This is like, we have actual simulated attacks here, so it's not something like we just put together for this demo, but it was picked up properly and explicitly exactly what happened. And that's the important part. You read that summary as an analyst, and you immediately understand why this was presented to me versus anything else. So that's really, really cool. And then if you look at the details, we don't need to read through all of them, but it basically goes into the chronological order of events, how this attack played out, which is, again, help the user who's using your AI feature to understand exactly what happened and why you even came to this conclusion. So we show the user exactly all the details step by step. We show them all the entities which were involved, and finally what the actual outcome was. And that's really, really important. We give them some other visual indications of like the attack chain, whatever. These are just to make it look and feel a bit better. But hopefully you can see like this would not have been possible in the time it took to do without a large language model. And that's what's really important. This is what LLMs are really good at, doing things in a way which really speeds up the analyst experience.
Hey, James, real quick, before you jump to the next piece, well, I want to highlight something because, again, when I was in a SOC, I think the thing I was really worried about was how many people spend, you probably have a dedicated person on false positive reduction, right? Which is like, you get to the point where I want to make every alert actionable. The problem is, all of a sudden now you have a bunch of stuff that was missed, right? This detection gap you've created where adversaries can live, that is, you've narrowed your, say, machine learning so narrow now that anomalies that you need to pick up aren't there, or you've made your detection so brittle that one change now isn't there. So the philosophy change that we want to implement for people, regardless of what you use when you implement AI, is think of alerts not as every single one is actionable, but instead now they are context for the next layer of analysis. You can actually widen the aperture. You can be even more verbose in the anomalies you look for, and then allow another layer of analysis, like an LLM, to apply to that context and then give you that result, which is now the thing to look at. So kind of changing your view on these alerts, and James always likes to joke that alerts are really just logs. You have billions and billions of events per day, you've narrowed them down to maybe thousands, but then don't keep narrowing them. Now apply another layer like an LLM to filter that to what really matters. That's the best way to sort of avoid this detection gap where an adversary might sit outside of that window. Thank you, James.
Thanks, Mike. So cool, this is great. So this is just a really nice example of how you can apply these techniques outside of chat. And this was actually one of the things that excited us most, because once we figured out this is actually possible, we've identified a bunch of other use cases. But if we did have to take chat into consideration for a second, here's where we find it extremely valuable. So let's say you're given something like this, a really nice summary. We know exactly what happened in the attack. Problem is now, usually, you have the next half of the battle. Like, what do we even do now? Like, how do we start to remediate it? Who do I reach out to? That sort of thing. Where traditionally, you might have a whole list of playbooks that you have to sift through, find the right playbook for the kind of attack you're looking at, follow it step by step. Very time-consuming process. And this is where, again, RAG is really, really beneficial. By the way, of course, you can take additional follow-up actions, you can create cases or whatever. But one of the things we wanted to do is have a really nice quick pivot to something like an assistant. Because the assistant, once you give it the right context, as Mike was saying, in terms of what you want it to do and achieve, it can answer any kind of question. So within our implementation here, again, one of the things we made really easy is bring in any bit of data that you'd like. Right? So that's really important if you're thinking about these kind of systems. Does it let me bring in additional context that I can ask questions about? And that's really what it boils down to. Is there any bit of data you want to make available to your teams in natural language? That's how you should be thinking about this. And one of the most obvious examples is, okay, well, yeah, I have a whole directory of remediation guides or standard operating procedures or whatever. I'd love my users to be able to just ask about them. So in this case, we have this attack. Let's ask what our remediation step is in this case. So it's like, look, the question I asked there is, how would we remediate and respond to this attack on this particular Windows host? Include any relevant guides and render any videos that you might have. So that's also a possibility, right? Because these models can handle all these bits of information really well. So in this case, as you start to see it come with its answer, this is an answer bespoke to me and my organization because of that additional context that we provided. This is not some generic answer. So you can see here it's telling me, look, it even identified that these steps are specific because we're running a Sentinel-1 host here. As an example, like, you might have specific playbooks for dealing with specific things. So it was able to identify that based from the attack context. And then it's telling me things like remove the malicious files, clean up the registry, monitor for further activity. But then it's also identified that, look, hey, you're living in Elastic world here. Elastic actually has a way to reach out to Sentinel-1 host directly, as an example, instead of you going to the documentation to figure it out. Here's a nice little video for you to follow. So as an analyst, the fact that I have all this information available to me right where I'm investigating an incident Just makes my life 100 times easier. So I don't have to go and fish all of this stuff out. It's just available to me. And then I also know who's responsible for this host. So this Windows host is owned by Jimmy Beans. Here's their Slack handle. Here's a link to your investigation wiki if you need even more information. So look how many answers we got purely because we're adding that RAG layer with one simple natural language question. We got all these answers that would typically take me a long time to get to. And that's really the point here. How can we make that easier for our users with this concept of retrieval augmented generation? Now, we don't have to stop there. This was a very obvious example, right? But there are some other examples which aren't that obvious. The way I like to describe it is any bit of text which is hard to operationalize in a security operations team, using RAG, you can make it useful again. And I'll give you a really classic example. Threat intelligence reports. I'm not talking about IOCs, that we know how to operationalize that within a SOC. You can bring that in, whatever platform you're using, very, very easy. But a lot of our vendors that we work with, they give really incredible content, but I get it in the form of a PDF, or I get it in the form of a blog post or whatever. During an incident, you can't really expect your analyst to go, oh, let me find the right PDF to try and see if this attack matched anything that my vendor told me. Perhaps there's some analysis I could do, which they pointed out. You can't really expect your team to do that, right? It would be a very time-consuming, complex process. So if you bring all of that in as additional context, and then you can ask questions about it. So as an example here, I have some intelligence from, again, our threat research team. I ask a very generic question. Does Elastic Security Labs, as an example, have any information about these types of attacks? And this is where that NLP, that natural language processing, really comes in, because I didn't really structure a question about what kind of attack I'm looking at. It identified what I'm asking because of the rest of the context of the conversation, which makes it 10 times more powerful and more usable. And you can see here in this case, yes, it found the match. It told me why the match was there. It told me to use similar tools like certutil, PowerShell, whatever. So imagine you give this capability to your user where they can ask these kinds of questions about that really rich threat intelligence content that you might have just sitting around on your desktop doing nothing. And you've probably paid for it, so might as well put it to good use, right? So that's another really good example of this. But we could take that a step further. You know what's really valuable during an incident, but again, it's impossible for someone to operationalize? Think of network configurations, switch configs, firewall ACLs. In this case, it told me, for example, this particular attack that was identified, there was data exfiltration via Slack, right? Wouldn't it be great if I knew which firewall actually allowed this egress traffic? What am I supposed to do? Give my team, hey, here's our ACLs, go figure it out, or call up our firewall engineer, hope he's there, and see if he can answer the question for you. That's not going to work. In this case, you grab all those ACLs, you grab all those firewall rules, chuck them in as context to whatever tool allows you to do this, and then you can ask a natural language question about it. So in this case, we can say, look, based off of our rules, which rule would have allowed this outbound traffic to Slack from this particular Linux host? And again, I kept it very generic, right? Because it's in the context of what I'm asking. In this case, it was able to identify that. You can see it told me this is the firewall rule, this is everything it did, it's allowing egress to everything, which is obviously not great, so on and so forth. So really, really powerful to be able to do that kind of thing. And it just goes, some things aren't that obvious, but I like to describe it as make data which we probably already have somewhere. It's not doing us any good just by sitting there. Make it usable, make it more valuable for you. The last example I show in this particular context of chat, because there's some other things I'd love to show you, like what we've learned, is, as Mike was saying, we probably log all our incidents. We probably know exactly what we did last time. In this case, as an example of our firewall rules, we have a process we should follow, right? We have a change management process. Someone logs a request to implement a rule. Why don't we check, based off of that data, if this rule we've just identified was a legitimate request or not? Or was it put in as part of this attack, as an example? I don't want my team to have to go to our Jira or wherever you store your incidents and fish all of those out and try and find the right one. That's never going to work again. So in this case, bring that in as context and ask the question about it. Is there a Jira change request, for example, where this rule was requested? If so, give me a summary of the request and a link to it. In this case, it found that request, and it told me exactly what it is, who the requester was, if it's complete or not. Here's a direct link to it, so on and so forth. So just to give you ideas of why we focus so much on this and why we share all of this context out, because you can really make cool things with it. So that's from a chat perspective. Another example where we found that this concept of retrieval augmented generation really helps. And this is something that we've been focused on quite recently, but again, we really like to share kind of how we've been thinking about this sort of stuff. So it's very common, especially if you've lived with a SIM vendor or whatever for many, many years. You've probably built a really rich repository of things like detection content or hunting queries or whatever, really valuable. But then you might have switched provider recently or something like that. You want to use them with your new technology. All of a sudden now I'm in a situation where I can't really use that rich repository of rules that I've been maintaining for the last X amount of years. So we wanted to see, can AI and retrieval augmented generation help with situations like that? So we actually built out this nice interface here as an example of doing this, where people can bring in detection content from other platforms really simply, and then we use RAG to do that conversion. So, and just to show you an example of where that is applied, so here as an example, we brought in some content from another system. It identified that, hey, we're able to fully translate almost all your rules. There's some that need some additional input. But where does RAG come in? Where does this context come in? So as the vendor you're moving to, they probably have a really rich repository of rules and stuff they provide out of the box. And because we know the cost of LLMs can keep growing over time, one of the things we do first before just translating for the sake of translating is, can we use RAG to actually match the rule you're giving us to maybe a pre-built rule that your vendor is giving you? So that's actually something that we found works really well. We actually have a model, grab like keywords from the query that's being converted, see if there's a match against rules, and if it does, then okay, we found a match. We don't really need to convert this for you. Let's save you some time. Let's save you some tokens instead of doing that. But if we didn't find a match, and then we can go through a full conversion, and this is where like LLMs really shine because they can infer information from what you're giving them. So if it identifies, hey, you're trying to translate an AWS query, here's everything I know about AWS, for example, let me make sure it's added to the context of the query that we're converting. So in this case, as an example, we grabbed a rule, and we converted it to an equivalent within our context. But this can be applied to anything, right? Like Sigma is so popular as an example. Everyone wants to apply Sigma everywhere. It's been really hard to find like a proper translation layer from Sigma to pick whatever vendor of choice. LLMs solve that problem because they know your context, they know your schema, they know your field structure. So applying it that way really, really, really helps. So that's another example where we see a really clear use case for this in challenges which are traditionally really, really hard, time-consuming, and expensive. One last one for you before we move on to some Q&A is data sources, right? We all have data everywhere. But the challenge is, if you want to bring that into a platform that you're using for security analytics or whatever it may be, if it's a bit of custom data that you might, is bespoke to you and your organization, the vendor you're working with probably doesn't have like a native data parser or data collector for it, right? And traditionally, that means my team has to spend time building something custom. It can take anywhere from a few days to a few months to do it. If I have many of these sources, it's going to take me even longer. So we're like, OK, how can we put AI to good use for these use cases, right? Is there an application for it there? And actually, there is, right? So one thing we can do is, based off of a bit of sample data that's provided, these models can generate fully fledged data parsers or integrations. And then you can even have, with this whole concept of agentic AI that we've been hearing about, one of the beauties of agentic AI is it can do things like validation loops. So that's actually something we found works really, really well as well. Just to show you a really quick example here, again, you can take this concept and apply it, pick your other tool of choice. But traditionally, something that would take time, we're going to do it in a matter of minutes here. Once again, you can pick whatever large language model that you'd like, which is also something that's really important. We're going to create a custom integration here, so we'll just give this a random title. Let's call it RSA. Let's just name everything and keep everything RSA. How are you going to collect this data once you create your parser integration? And then the last step is, OK, give us a few sample log lines, because the large language model is going to use that to be able to do whatever it needs to do. So I have a little bit of a log sample here. I'm just going to drag this in. And in the background, this is like one of the first agentic things we experimented with because we wanted to see how valuable it is before actually implementing it. So really and truly, if you've heard this term agentic, all it means is have a model decide on the next steps based off a set of instructions that you've given it, right? That's really all it is. So in the background, the LLM is checking, okay, the user provided some sample data for us. Do we need to parse anything out? Do we need to normalize anything based off of this user's environment? Do we need to categorize things in a way? And every step of the way that it takes a decision, that is an agentic action. That's really all it is. So this is what it's doing here, and it's also doing validation as part of that last agentic step. So by the end of the time this finishes, which takes a few minutes depending on how many samples you actually give it, you'll end up with a fully fledged, what we call parser or integration or whatever, that again would have taken a very, very long time. And not to say that it wouldn't have been possible for a human to do, absolutely it would have, but why not have your team focus on the things that interest them versus the mundane, like building a silly parser. And here you can see, did a really good job, it parsed everything out, nice and neat. But what we like, again, in the full essence of transparency, what we found really important is show a user how much effort you've actually saved them. So if someone had to build this manually themselves, they would have had to write 386 lines of JSON, which nobody wants to do. Awesome. So that's really what I wanted to demonstrate today. Again, all really classic examples of things you can apply and where RAG really fits in. We're happy to take some questions now. We have about 10 minutes that we can take some questions for. And we'll just remind you, there's the mics in the middle.
Yeah, please come up and ask some questions, yeah. But I think, and as you're coming up, I think the key thing to think about is your company's investing or looking at AI. The reason we love RAG is, you noticed earlier all those different models. The whole point of RAG is you don't train a model. And models are coming out so fast. They're getting cheaper, they're getting faster, stronger, all those things. When you lock in with your own tuned or trained model, you're stuck there. And when a new, better one comes out that's cheaper, it's so hard to move over. With RAG, it sounds maybe complex, it's not. You're literally just putting, let's say, firewall config data. Super small, super inexpensive amount of data, throw it down here, have it be vectorized by whatever system you're using, and then put it in its context when you go up to a question. That's it. And now any model can have that and actually give you these bespoke answers. So it's such an amazing way to get very, very tailored information. It seems like you data scientists have spent months and millions of dollars building out your own model, but they haven't. They just simply added context. And as I mentioned, this used to be difficult because context windows were small. Now they're massive, and they're only getting bigger. So you can literally send, as James was showing, what happens behind the scenes in any system, but we'll take ours for a second, like a hybrid approach. You first look at, you see what the question is, you interpret that natural language, you go see if there's data relevant to the answer, add that context, go to the LLM, come back with a bespoke response. That's it. It's that simple. And so as long as you have whatever platform you use, and pretty much every vectorized store can do this, you throw data in, make it useful. If you're already going to store it, why not store it over here where it could be useful versus like somewhere in a snapshot you're never going to look at. And you can, the sky's the limit on what you can do here, as James was saying. Really, configuration data, ticketing data,
anything.
CMDB data. We have people that are doing things like risk analysis based on, HR data. All kinds of stuff now becomes accessible to, as an analyst, that it's impossible to get this information. You're sitting there making requests, opening tickets. Maybe a day later, somebody responds to you. So how can I get your team to be as actionable as possible and really reduce that deficit of response? And let your analysts actually do analysis, surprise, and not data wrangling. Please feel free to ask questions. Anybody wants any? We're here.